Hi Year 11, this is the first in a series of lessons for our second topic, which is functions. Here's the lesson outline. We're going to look at functions and relations, dependent and independent variables, types of relations, vertical line test and horizontal line test, function notation, and then finally piecewise functions. Now a relation is just a set of ordered pairs, x, y, where there's some relationship between the variables. For example, y is equal to 2x. Now we say that x is the independent variable in this case and y is the dependent variable because it depends on what value we put in for x. There are four basic types of relations and sometimes we call a relation a mapping. So there's a one-to-one mapping. So each item in the first set maps to exactly one item in the second set. There's a one-to-many relation. So in this case, we can see the number 1 maps to two different elements in the second set. There's a many-to-one. So here we've got two different numbers in the first set mapping to one number in the second set. And there's a many-to-many, which is where we've got 2 going to 1 and 1 also going to 2. Let's look at some examples. Which of the following are examples of a one-to-many relation? So as we're looking through here, we're looking for duplicates. So having a look here, we've got two 2's that map to different y's. So this is an example of one to many. We've got the same thing here. Same x value mapping to different y's. We've also got to check the y values. 3, 1, 0, 5, they're all unique. So this is a one-to-many relation. This one here, we have actually unique x values and unique y values. So this is one-to-one. Here we've got 3 zeros all mapping to different y's. Now let's check to see whether we've got any duplicates in the y's. We do. Look at those, 2 zeros coming from different x's. So this one is many-to-many, it goes both ways. And then finally this one, 2, 3, 3, 3. So we've got the same y value coming from different x's. Do we have unique x's? Yes, we do. So this one is a many-to-one. Here's example 2. Describe this relation. So we've got various people and their pets, and we're going to assume that the two Jameses there are the same person. So we obviously don't have one-to-one because we've got 2 Jameses and 3 dogs. So we've got duplicates. Do we have one-to-many? Yes, we have the same person with different animals. And we've also got many-to-one. So this relation is many-to-many. A function is a special type of relation where there is one and only one value for y for any given value of x. And one-to-one and many-to-one relations are both functions. So there is only one y value for any x. Can you see that? Even this one here, 1 only maps to 2 and 2 only maps to 2. So these are both functions. Now relations can also be represented graphically on a Cartesian plane. They can be easier to see. This is a one-to-one function, y equals x minus 5. There is only one y value for any value of x. Now, in this case, the independent variable is always put on the horizontal axis, and the dependent variable is put on the vertical axis. And this is a many-to-one function. So throughout this part of the graph, there are 3 separate x values that map to exactly the same y value. Now, this is an example of a relation that's not a function. In this case, we have got one-to-many. So through here, we've got a single x value mapping to different y values. An easy way to see if a relation is a function is to use the vertical line test. If a vertical line cuts the graph in more than one place, it's not a function. So let's have a look at those 3 examples. Here's my vertical line. As I move this across, it's only ever cutting that line once. So that one is a function. Now here, as I move it across, we only have one y value for any x. So it is a function as well. But can you see that this one is not? All over the place, it's failing. So there's two y values for any given x. Now, if we find out that our relation is a function, like these two examples, we can use the horizontal line test to determine if it is one-to-one. If the horizontal line cuts the graph in more than one place, then it is not one-to-one. So let's look at that. Here's our horizontal line. It's only ever cutting in one place, so this one is a one-to-one function. But this guy, it's not. Okay, in that middle there, it's cutting in 3 places. Let's move on to function notation. If the relation is a function, then we can use this notation. And we say f is a function of x, or f of x for short. Now instead of writing, for example, y equals x outside of x minus 1, we're going to write f of x equals x outside of x minus 1. Now, we don't only use f of x, but it is the most common. We could use g of x, or h of x, or even phi of x. Let's look at some examples. If f of x is equal to x squared plus 5x plus 1, find the value of f of 1. All we do here is substitute the 1 in where the x is. So this is pretty easy. It's 1 plus 5 plus 1, which is 7. If you want to substitute a negative in, make sure you do so using brackets, because a negative squared is a positive. So this is 9, take away 15 plus 1, which is equal to negative 5. We can substitute another pronumeral in. So a goes into here, becomes a squared plus 5a plus 1. Or we can substitute in a more complicated algebraic expression like a plus 1. And again, use your brackets. So substituting in, we get this. And then it is expected that you will expand that out and simplify it. So we have a squared plus 2 times a times 1, which is 2a plus 1, plus 5a plus 5 plus 1. Tidying it up, we get a squared plus 7a plus 3. Here's another example. This time, instead of substituting in for x, we're going to solve the equation f of x equals 0, which means the 0 is going to go here. Now, we've done this before. This is just a null factor law. Either this is equal to 0 or this is equal to 0. So x is going to equal 1 or negative 2. Let's move on to piecewise functions. Now, you probably haven't seen something like this before, but it's just a mixture of different functions joined together. And each of these functions is going to have a specific interval where it is defined. So it looks like this. Here's our sideways parabola, here's our normal parabola, here's our straight line. Now a function is continuous if there are no gaps. So if it goes seamlessly from one into the other, which this one does. So this is a continuous function. A function is discontinuous if there is a break or a jump. We can see that here. Now it might surprise you to know that this is still a function. As we go along, there is only ever one y value for any given x value, even here. Because we've got the open circle, which means not equal to, and the closed circle, which means equal to, at this particular point, x equals 1, y is equal to 2. So let's return to this function. Find the value of f of 0. So we've got an added complication here. We've got to find where x equals 0 is valid. It's not here. It's actually here because we've got the equal sign. So we want to substitute the 0 into here. So the answer is 0. F of negative 4, well, that's here. Now this looks alarming with this negative, but it's actually going to multiply by that negative and give us a positive. So square root of 24. And finally, f of 6, well, that's up here. So substitute it into this function, which gives us 15. Okay, that's it for this lesson. Our next lesson is on the graph of a function.